This Week in Radio Tech, episode 210, is brought to you by the Telos Zip 1 IP audio codec, remote talent, outside broadcast, studio transmitter links, and convenient remotes with Lucy Live smartphone apps. The Zip 1. See it at telos-systems.com. Snmp stands for Simple Network Management Protocol. It's been an IT professional's secret weapon for some years, and now broadcast engineers are using it too. Charlie Toner is on top of the Snmp game for broadcast gear and talks with Chris Tobin about putting Snmp to use.
Welcome to This Week in Radio Tech. I'm Chris Tobin. Kirk Harnack is down under and unfortunately has some bandwidth issues. He's down under in Australia, not something from a night of having too much good time. And our guest today is Charlie Toner, so we're going to talk about some good stuff. So welcome to the show. And as always, be sure to check us on demand if you can't stay with us long enough for this next hour. And this show was on Snmp, so you definitely need to take a look-see. Probably best to do it on demand if you can't stay with us for the full hour, because you want to sit back, enjoy a cup of tea, coffee, or maybe your favorite adult beverage, and take in what we're going to talk about today. So with that, without further ado, let's go to Charlie and bring him in. And
hi, Chris.
Yes.
Just saying hi. Thanks for having me. Sorry. It's been a pleasure. I've become a TWiRT fan in the last year, and it's been a wonderful, informative platform for just about everything. Like Kirk says, from the mic to the light at the top of the tower.
That's our goal. I mean, it's basically conversational. It's as if you and I were sitting at the NAB, whether it be 2012, 13, or 14, having a cup of coffee in one of those public areas and just laughing about stuff and sharing some experiences. And now what we do is, on the show, we bring it out to the masses. And I like to think
we were doing a couple of weeks ago, if I remember correctly.
Yeah, that's correct. We were. So I like doing this. And I've been up, and make sure I have this straight. You're just outside Toronto.
Yeah, we're about, I'm at our Peterborough studios for Magic 96.7. We're about an hour and 20, 30 minutes out east or northeast of Toronto. It's still actually cool up here.
Oh, yes, absolutely.
It's been raining.
We're lucky. The rain left us. So the reason I make the reference to Canada is because I enjoy my relationships and friends I have up there. And for those in Canada that can recognize this, the CCBE, it's the Central Canada Broadcast Engineering Conference, which is a very fun conference in a resort in Barrie, Ontario. And
I will be there again.
Yes, I look forward to it. It's always fun times. So I like to say thank you to the folks up there from where I sit, and in your neck of the woods from Toronto, to guys in Quebec and elsewhere that enjoy the show. I've met several times, and I just want to pass that on. And Dave Simon is one of them. And there's a few other guys I have to think of. So I mentioned Dave, and I know there's a few others. And there's Ron Paley. Those of you in Canada and over on, and a few others. So just want to say thank you for.
Ron took me out to dinner at NAB, and I think his brother Ted and I talk probably twice a week about something or somebody. So we have a good relationship with the Paleys.
Yeah. So Ron Paley and his company, Digital Jukebox, has a few folks. Joe Myers, who I used to work with with the other companies, is enjoying nice new digs, and also Mr. Parsons, the software guy who makes it all come together for Ron and Joe and the others. So if you have a chance, check out Digital Jukebox for your automation needs, and just say hello to them.
They won some awards at NAB, actually.
Yeah, they did. They did win awards.
Yeah.
And
it's a Best in Show. Their Logger won Best in Show, if I remember correctly.
I believe that's correct. Yes. So if you happen to talk to those folks,
on the software here.
Yes, that's what I heard. So be sure to let them know you heard about them on this show, This Week in Radio Tech, so that we give credit to both parties. And this way people know that we're being legitimate about everything. So, Charlie, tell us a little bit about where you are, the broadcast group you're with, and your participation in the success of your broadcast group's money-making ventures in radio.
Well, Pine Ridge Broadcasting is a very small, locally owned group of 3 stations, and then we're also affiliated. We share engineering resources with another group called Durham Radio, which is just a little bit to the west of us, for a total of 8 radio stations. It's a very dynamic group of stations. everything from one that is a jazz station out of Hamilton that does webcasting only, and then the other 7 stations are all off-air broadcast as well as streaming. The station I'm in right now is actually our newest station of all 8 stations. It was built about 3.5 years ago. All digital IP platform from microphone processor right through to the transmitter. And it's been it's actually one of my most stable and easily maintained radio stations of all 8 is the best way I can put it. It's been a very big success. And a lot of it has to do with how we've moved on with technology like Davicom or Burke. I know there's a lot of people that prefer the Burke over the Davicom or the Davicom over the Burke. We're using Davicom. We're using Nautel transmitters. And they've really gone a long ways with their Snmp monitoring and control and management with all of these different platforms. And it's made a huge difference with the ability to sit back with a laptop on a beach in Jamaica, which I actually did the first year that we broadcast, and fix any issues or problems or reroute audio and get rid of echoes or whatever on the soundboard from the beach.
Now, that's the best part I enjoy about the newfound technology, something that is foreign to many of us in broadcasting. The ability to, from an outside location, control your facilities thousands of miles away while you enjoy a nice beverage on a beach shore or maybe at a resort. And yet, I still come across folks who have an issue with IP and just can't seem to get their head around it. So I'm hoping with this episode, we can start the process for people to start learning and understanding that IP can be friendly and can be robust as the familiar TDM ISDNs, T1s, E1s, even Switch 56 for those of us that still have the old stuff. And this show is going to talk about Simple Network Management Protocol, otherwise known as Snmp. And for those of you who may not be aware, this is an internet standard protocol. It's designed for managing devices over an IP network. Correct, Charlie? Do I have that right?
That is correct. It actually started in 1992, and I actually come from the networking industry when I got into engineering back in the, it was back in the 80s when I started in computers, and late 80s, and then into the 90s with network and network infrastructure. 1992 was when Snmp 1 and then 2. 1994, I believe, Snmp level 3, which is a much more secure system, which is the protocol that manages basically all network traffic, whether it be public internet or business network, is all managed in one way or another, or available to be managed through Snmp.
So basically, if you believe that the internet, or IP, I'll say the IP, not internet, the IP technology is immature technology, it's time to sort of step back, get rid of that old encyclopedia, open up the laptop, and start researching, just so you know. Because 1992,
it's been around for a long time. 1992, I was also involved in radio, and I was still spinning vinyl. I was still playing commercials on cart machines, and we had a VCR machine for our logger. So the radio business has come a long way since those days.
Absolutely. I'm excited about it. And I've actually helped a lot of folks put together some nice networks and systems in broadcast. Because broadcast, as we all know, is a different mindset, mission-critical thinking, always up time, 99.99%. So that's 4 nines reliability. Unlike other industries where they say 95% is what they consider the best. And, we in broadcasting would consider that a really bad day. So, Snmp, once you get fingers into it and understand it, can actually help you to really deploy a nice network, all the equipment, devices, and you can rest assured that you can sleep nights and know that things are under control. So let's start with this. I have a question. I've had several people over the years ask me, I have a device or several devices, and I want to use Snmp. For the broadcast environment, what is the basic or a entry-level approach someone should take to sort of build that foundation so they can start growing it growing their Snmp architecture as their plant expands?
Well, the first thing I do right now is anytime I'm buying a new product for broadcast, a new whether it be a codec or a switch, I usually go with a managed switch. Right now we've standardized on Cisco managed switches. We've got a bunch of 2960Gs that we're using right now for our both our IP network, our audio over IP network, as well as our office network. We have two separate networks that we utilize. That's kind of important. Make sure that it has a good Snmp capability. And when you order or purchase that product, make sure you get the MIB file. The MIB file is the definition file of all the Snmp characteristics, and we're going to get into seeing actually a MIB file for a Nautel VS transmitter.
Question, if I may. This is the question that comes up a lot. You said a managed switch, which I understand
Yes.
the reason for that. Explain why I'm building a network in my facility and I need to I need to use a managed switch. In your case, it's a Cisco 2960G, a very nice switch. Why should somebody be concerned about the type of switch, managed, unmanaged? What's the difference? Why should I care? And I can get an unmanaged switch for 30% less than that managed switch. What's the difference? I say this only because
you could probably get an unmanaged switch for a lot less than 30%.
Well, yeah, no, I'm sorry. I'm just using the numbers. I'm just
They are more expensive, but the managed switch allows you to manage traffic dependent on what the traffic is meant, where it's going. It's basically having an entire group of traffic cops built into your switch that allows you to manage the traffic and to control that traffic to make sure that if I'm asking for the IP address for the transmitter, I'm sending information to a transmitter or to a codec, which is very important, that the quality, the channel or the path through the network, which can get very, muddied water if you don't use a managed switch. It's not broadcasting across all the unmanaged port. It's actually going to exactly the right port, the right connection all the way through and to the point that or destination that it needs to go to, and the information coming back through that channel. So in a layman's terms, it's having the best possible, best educated traffic cop as part of your network. And that's kind of the whole infrastructure. That's the bare bones, making sure that you have the right highway system and the right traffic system for your network traffic to maneuver through your network and do it seamlessly and fast.
So basically, if I'm a broadcast engineer, technician, an IT guy doing broadcast work, and someone says to me, boy, I sure like the old days of ISDN where it was reliable, I made a connection up and went, you could sort of say using managed switches in your facility can give you the equivalent of quality that you've always had with a TDM type system, say ISDN or T1s. Yes?
Absolutely, yeah. And we actually use a T1 line to our transmitter site here. And it does a great job. It does a wonderful job. We also have fiber optic that's going in and out of our studio groups and between the studio groups, so we can actually see through our managed network and our fiber optic connections and all of our routers and everything else that are all managed and all have Snmp capability. We can monitor the path of data and make sure that data is getting from point A to point B absolutely the best way it possibly can, reliably, every day, no matter what.
And now that exactly is what I've told folks. I've been to several meetings and talked to broadcast groups about IP and general basic stuff. And there you've explained it. You've said it exactly what I've tried to tell everyone. Years ago, when you ordered an ISDN line or T1 or MPLS, not MPLS, sorry, T1s, E1s, or any kind of DS0s, DS3s and stuff, the phone company took care of what Charlie just said, making sure from point A to point B, everything in the middle is properly managed and gets there. Now let's flip this to 2014, and we've got a device or a technology called IP. Phone company says, here's your pipe. Whatever you stick in it is up to you to manage. Basically, that's correct, right, Charlie?
That's correct. And so, yeah, they have offloaded a lot of that management to us. And to tell you the truth, it's a good thing they did, because phone companies, as much as we deal with them and love them in many, many ways, do not understand the demands of broadcasting in either radio or television. And that's the reality of it. They're not broadcasters. If they have an outage, well, they'll get it. They'll have it fixed within 4 hours. What happens within 4 hours of being off the air in radio. You usually get a few more phone calls from people that sign your paychecks.
Absolutely. And I'm actually working with a department within the Department of Commerce in Washington, helping them look at going from the old phone system approach to distribution of what they do to an IP approach. And the questions they keep asking are the same ones we're answering right now. So I'm glad to hear that you're explaining it the same way I've been explaining to others, and it's not just me walking around, beating a drum and saying, guys, it's possible to do things. You really can. So I'm glad to see we're on the same page. So let's move forward. We're talking SNMP, managing our devices on our network. Continue on with your basic layout. I've bought my managed switch. I have a network that's set up for my broadcast revenue generating LAN. That's what I usually call it. And now I need to begin the thought process of how to lay out my SNMP management, I guess I'd call it.
Well, I kind of happened into SNMP here a little while ago, playing, and I spent a lot of time playing with it. And what happened is we have Davicoms that are at our transmitter site, our monitoring and control, and because we do have to have control of our transmitter sites remotely as part of our CRTC license, much like you do as the FCC licenses that you have. And we have Davicoms in our studio blocks as well. Well, a lot of the IP and digital audio that we have, if something goes wrong, you need to have something that will make a decision on site without necessarily being there. This is one of my remote station sites from where I live. It's about an hour, a little less than an hour's drive, but in an off-air condition, I'd like to be able to control both the studio and the transmitter site remotely. So we have Davicoms. The week before NAB, we actually had one of our units fail. I've never had one fail before, but something happened in the software and it just kind of hiccuped and wouldn't come back to me for a bit. So rather than having to rewire and have another unit overnight expressed, I actually used the Davicom unit at the transmitter site and took all of the commands that I would normally use to control our studio site, which also is our network operations center, and I moved it all to an off-site Davicom. Now, we have about 6 Davicoms throughout all 8 stations that control all the transmitter sites. There's 12 locations. And there's a lot of double duty with these Davicoms, and they see each other. So we could actually move all of the programming from one unit to another unit in another city and still control the studio or the transmitter site or anything, all remotely through SNMP. We didn't have to run extra wires. It's just the pipe is already there. We're just throwing a very minute amount of extra traffic on it.
Now, the Datacom, just so I understand, is a product, or is that just a term you're using for data communications? Just so I have that right.
Davicom.
Davicom. Sorry.
Yeah.
Davicom. Gotcha.
You know Andrew.
Oh, yes. Sorry.
Everybody knows Andrew.
Unfortunately, my little earpiece thing is not the highest quality. It's one of those acoustic tubes, and I should change it out.
It's the same idea as a Burke, or very similar to a Burke, yep, which a lot of people in the U.S. are familiar with as well. They're both excellent systems and excellent companies. I do like the SNMP manager on the Davicom a little bit better than the Burke, but I mean, that's my preference.
Yes, no, Davicom we have had actually at the SB meetings here in New York City, so I know exactly who you're talking about. They do have a very nice product. And I actually have used it over the years, so I would agree. Nice. All right, continue on with your moving along as we build out our SNMP network. So the SNMP network that I've been able to design is very portable in the sense that you can just grab all of the addressing and commands and what you're looking to get for information and how you're going to send commands, traps, and things like that. And that is very mobile and movable, and as long as you can see the device, you can ping the device with a simple ping command, then you can get that SNMP data back and forth through it as well. It's only 2 ports, 161 and 162. It's a very seamless and very, very little traffic. It's very, very light as far as bandwidth. In this location, we have fiber optic to the internet, fiber optic between this studio location and our studio location and head office in Cobourg, Ontario. And we have T1 lines going out to our transmitter sites. Through the managed network that we have, using SNMP to manage the traffic, we can reroute traffic or even studios. For example, we can, in an emergency, whether we have a flood here in Peterborough, and this has been flood season, but Peterborough has been spared this spring.
And we are in the basement or very lower level of a mall here for the studio. So if something tragically happened to this studio, we could very quickly up and just move all of the function and form and control of the transmitter site, which is up on a mountain, move it to another city or to another building or another studio, all very quickly. It's not a matter of having to rewire. It's a matter of plugging in a bunch of Cat6 cables.
So when you speak of being able to shuffle your MNC, your monitor and control, from one location to another, do you do this with any particular scripting, or is it just, as you point out, a cable move, so you're moving ports and just where you're directing the control? Is that just so I understand and for those listening and watching?
In the case of, I might be able to just bring it up.
Bring it up. You're watching and listening to This Week in Radio Tech, episode 210. Charlie Toner is talking to us about Snmp as he brings up his screen share and smiles and laughs at the fact that I'm now narrating a visual. For those of you in the radio audience or listening audio audience, imagine a person in front of a computer screen trying to bring up something else.
I keep forgetting that there's also a there's also just a podcast, an audio podcast, so it doesn't have the video part of it.
That's true. You know, I always kid folks that we now live in a visual world, even though the auditory portion is the best part of it.
So this is actually the Davicom. This is my screen of the Davicom that we have in the studio block. And if I actually go to my Snmp page, I'm just monitoring two different transmitters, my primary and my secondary, that I have powered up on a dummy load. And these are, because this studio doesn't have physical hardwires plugging into the GPIOs of the transmitter, because it happens to be about 6 kilometers away, we're using IP. So this is Snmp command and control with get commands, getting all of this information, including the forward power, reflected power, PA current, PA volts, and VSWR for an efficiency for the A and the B transmitters. I have another unit at the transmitter site.
So as you're doing this, using the Davicom, you can control, manipulate your transmitters accordingly as you would normally if you, say, use the IP direct connection to an Autel transmitter.
That's right. This is the Davicom that we have at the transmitter site itself. I didn't duplicate the Snmp because it's local and it's locally controlled through the GPIO. All of these analog inputs and status inputs are GPIOs within the site, and a lot of them have to do with both the primary and secondary transmitter. Here's the thing about the difference that I found between using GPIO and Snmp. GPIO, when we go to calibrate the signal coming from the GPIO, the voltage, I find that I'm recalibrating these numbers in whether it be a Burke or a Davicom. I'm recalibrating these numbers every time I do an annual.
Oh, interesting.
However, in Snmp, those numbers are exact every time. Actually, I'm going to go to the other, go to my other Davicom here, because it'll show the numbers, because the B transmitter is up on the screen.
Now, is that because the Snmp is a more exact and using the get commands and everything else, it doesn't lose, or nothing gets lost in translation, so to speak?
That's right. There's no line loss. This is a digital signal from your, in this case, a Nautel VS 2.5 transmitter. It's a digital signal over IP. It's exact. There's no line loss that you have to account for, or voltage loss, or whatever you might have with a GPIO connection that we've used for 50, 60 years.
Oh, okay, very good. I'm just let me say, I'm just being cued that your video may have frozen, so I'm back to me. So what you now have is a network that you can control your facilities from anywhere you happen to be with a laptop or a smartphone, I'll assume. Now,
yes. The
question I always have for folks like yourself for building these types of systems, security. How do I prevent somebody from being a man in the middle, or hacking in, whatever terms you want to use. How do I protect myself? Say I'm a publicly traded company. Here in the United States, we have the Sarbanes-Oxley Act, which requires compliance for how to prevent loss of business due to malfeasance, basically. I'm not sure how it works with the CFRTC in Canada, but I'm sure it's probably similar with publicly traded companies as well. Your network, how do you protect yourself? How do you make sure you have a security appliance at the gateways, or if you don't mind, don't give anything out of school that could compromise, but just general stuff.
We do use VPNs at our gateways. I mean, we use a good, solid, strong VPN at our gateways. We have a firewall on the gateways. There's a lot of protection on that side, and we haven't had any problems. And in the case of our transmitter site, it's actually well hidden. I mean, it's on an isolated network that's only accessible from within our network. Either I'm VPN'd in to our office network, and then there's a bridge over to our transmitter network, or I'm in the building. So those are my two options.
Okay, so you take the controlled access approach to getting to your other endpoints rather than trying to connect directly to the endpoint from the outside.
Yeah, I'm not a big fan of just throwing something without a firewall between it and the rest of the internet world. It tends to get hacked very quickly.
Yes, absolutely. And one question before we go to our sponsor for this netcast. When you're using VPNs, I've always been a fan of VPN software using rather than just the default Microsoft PPTP approach. Do you use like a Cisco client or a VPN client, OpenVPN? Just curious.
We're using a Cisco VPN client. It's actually part of the RVO 16 that we have at our network operations center, and then we have RVO 42s in all of our other locations.
Oh, those are great little appliances. I use those. I like them.
Absolutely, I love them. The RVO 42 is actually our bridge through our fiber links that link all of our sites together. We use RVO 16s at the NOC, and we have another NOC in Oshawa. So NOC standing for Network Operations Center.
Right, exactly. Yeah, I built recently a transmitter facility and studio connection using the 16s, and their access is through VPN through the client. And they all looked at me like, "You sure this is going to work?" I said, "Trust me, it'll be fine. You'll do just fine." So I'm glad to hear you're doing the same thing. So I need to now go to our sponsor, the kind folks at Telos, otherwise known as the Telos Alliance. And resistance is futile, as some have told me. So here in my hands, for those of you who can watch this, is a Telos Zip 1. This is a broadcast IP codec. It's actually pretty cool. It also has basic SNMP, I'm told. It's a recent firmware update, so you'll all have that information. It's the IP. So basically, on the back of the unit, you have the ability to take analog audio, or AES, or those of you with LiveWire Axia systems, you can, I think there's my finger pointing to LiveWire. And then you have yourself a nice little setup. Now, the Zip 1 has the ability to, let's see, talk on various algorithms. We don't need to get into details about algorithms because you know what they're all about. What you need to know is the hardware is designed in such a way that you get the connection from point A to point B. You control it. You make sure you get the best connection, and you don't have to worry. And your worries are unfounded because you could also choose the SIP approach or the Telos server. I believe it's probably SIP server. I think they have a name for it, but I'm going to say SIP server. So you don't have to worry about remembering the IP address of the far end or the remote location. What you can do is you type in an alias into the directory, the phone book, and that's all accessible through the little knob on the front, and you can maybe hear a little beeping here and there. And then you can connect to the far end of wherever you look to be. Or you have somebody looking to connect to you. They look up in the directory, they find your name, your codec's name, and off you go. And if you choose, you can also use a software application from the folks at Lucy, and your smartphone can now become a portable IP codec talking to the Zip. Now, why would you want to do that? Well, let's see. Portable smartphone has some limitations, we know, because it's very small and limited connectivity, but the Zip is at a firm location, your studio. It's behind a nice setup, a nice broadband. It's also a device, as you can see as I rotate it in my hands. It's a hardware device. In other words, it does one thing. It takes IP streams, bring them in, and convert to audio for your broadcast. Doesn't worry about updates, USB ports not working properly, or waiting for a change in some kind of device driver. It doesn't care because it doesn't have to. And that's where you have the hybrid connection. So you have a smartphone and a Zip 1, and you're off to the races, as I like to say. So that's where we have there. Just remember, on the back, you have two connections, live wire and your WAN connection. So if you're a non-live wire facility, you still can talk to the box. And you could use the other port to manage it. So now you have your connection to the outside world, and then you can manage the box. So you don't fear, you're not losing out on anything because you don't have a live wire enabled network at the time that you make a purchase or use your Zip 1. So there we have it. And that's a very basic approach to the Zip 1. I don't want to confuse too many people about what you can and can't do with it. And the best part is it's simple to use. It's intuitive. If you've ever used a Telos product, you know exactly how it goes. So Zip 1 follows in the same vein. So it's the IP codec that drops JAWS, not audio. If you have a very poor IP connection because you didn't manage it properly, as you've been listening to us on this particular episode with Snmp and managed switches, then it's your own fault for not getting a connection that you like. The box didn't do it. It's the connection. Remember, you take two zips, put them back to back, put them through the paces, and you'll find they work very well. Put them on a network that you don't properly manage or want to work with, well, the results could be very dicey. The zip, though, gives you the tools to make sure that you don't go there. These are all the things we're going to talk about over time through This Week in Radio Tech, and you can contact the folks at Telos. You can drop me an email. I'll be more than happy to talk to you about it because I'm helping promote and help folks install these things. This is, again, the zip is in front of me. It's a very nice 1RU device. Works very well. It's very well made, too. It's solid. So, not that you want to be dropping it or tossing it anywhere. And let's see what else you have. That's about it. And parallel control, GPIOs, and all the basic stuff. And everything can be done from the front panel if you choose, or you can use the web browser interface for the more detailed stuff. So there you have it. Zip 1, Telos, from the Telos Alliance. Check it out at the website, telos-systems.com, codec Zip 1. Or just go to the Telos website, click on the tab for codecs, and you could read from there all the different things that Zip can do for you. There you have it. Zip 1 from Telos. So let's get back to Charlie. I think you've been reconnected and the video's properly going. We have you there, Charlie?
Yeah, I'm here.
Oh, good. Okay. Where we left off, we had talked about the VPN, and then you were going to talk about some more stuff with your network and how things are going with the Nautels and how everything moves around.
Well, I could bring up something as simple as a MIB file using a MIB browser. And the MIB file is that definition file. It's what defines the address of every, piece of information that you want to get or send or receive a trap from. And those are the three things that happen in Snmp. You can get information, send information or commands, or you can receive traps or send traps. And traps are usually alerts, alarms or alerts or some other type of information that happens given a certain set of circumstances on the network. I'm just going to see if I can bring that up again.
And just so that you know, the MIB file, MIB, not Men in Black, but the Management Information Base, that's the proper term for the name, but everybody calls it a MIB. So make sure you remember this. That's important. So any device that you're going to use in an Snmp environment, you want to make sure you have the MIB file for that device. Now, don't panic. There are many devices, say audio codecs, that may not have control functions of the Snmp, but just strictly alerts. Okay, so that's still part of how you manage and use them. Just doesn't mean control is missing. That's a problem. That's just part of the implementation for that particular product. Correct, Charlie?
For example, we have codecs that are part of our STL, and the codecs are very simple in the sense that they do one thing. It's one direction audio going from point A to point B. And you could sit there and maybe have a MIB file that you could get the number of packets that are being sent across the network. That's kind of mundane, and you don't need to know the number of packets that are being sent at any specific time. You can always look that up on a device-specific browser or web interface or whatever. But if it's dropping packets, if it's dropping connections or information, or if there's some sort of a fault or alert on that device, that's when you want to have those traps. And most IP-enabled devices have the ability to send traps. So really, trap management is probably one of your biggest things. And you don't have to have a big, expensive Davicom or Burke system to do it. You can actually do it with something as simple as a free version of Spiceworks.
That's true. I have talked to folks that have used that. That's pretty handy. I like that.
So I don't know if you guys can see my screen or not. Oh, no, I didn't hit start. There we go.
We see a screen of a frozen Charlie toner at the moment and a spinning circle.
Ah, story of my life. Apparently so. Maybe I'm sharing too much.
Uh-oh. See, we're back to that bandwidth management issue again. You see, now, if this was an ISDN line, I wouldn't have these issues, somebody would tell me.
Well, it might actually be, have you got me back again, guys?
Andrew, do we have Charlie back? I only see myself at the moment.
Nope, Charlie, you're frozen. We got to reconnect.
Charlie's frozen. We have to reconnect. All right. For those of you tuning in or who have stayed with us, it's This Week in Radio Tech, episode 210. We're talking Snmp. And Snmp stands for Simple Network Management Protocol. And it's an internet standard protocol. It's used by many folks. It's been around, implemented and used since 1992. So those of you panicking that it may be something new and foreign, it's not. But the trick is, how do you manage it and best deploy it? Manage switches. You can do Cisco, you can do HP, you can do many others. Just remember, understand the building blocks, learn the inner sanctum of IP on a very basic level, and you can start evolving your network to where you want it to be. You want to be as robust as your traditional T1s and ISDNs, you can do it. It takes some time, but you now have control of all those parameters that would dictate how to make it robust. So let's see, is Charlie back with us? And do we have video for now?
I see my video.
We see Charlie. There we go. I guess we just don't have enough bandwidth for you.
I think it has to do with this computer. This is one of the computers that the jocks use during their morning show and afternoon drive show, and I think it's due for some maintenance.
Well, if it's anything like the radio studios I've managed over the years with the jocks, I'm surprised we're even seeing it right now. But it's just good.
All right. Well, I was just going to mention about using a MIB browser, iReasoning. And so if you think of the, just as it's spelled, iReasoning is a great little MIB browser. You can load the MIB files that you get from the manufacturer for your various IP-based products, whether they be traps or managed SNMP, where you can go in through SNMP level 1, level 2, or level 3. Level 3 being the most secure, by the way. And you can send get commands and send and receive or send traps as well, or set commands as well. And we're actually controlling our transmitter sites using SNMP. It actually works very well through devices like Davicoms, and we're also using it through Spiceworks. Here's basically the environment that we have here, where we have microphone processors that are digital. They're IP-based. We have an AOIP network. At this location, it happens to be Wheatstone. We've also seen it with other carriers and other products as well. But we're also available to with the managed switches, guys in the background, with the managed switches, we can actually manage the data going from every single point throughout the network right to the transmitter and right up the tower. We can measure the data going through the T1 lines, through the routers at the T1 lines. We can measure the data going through our fiber optic. We can measure the data going through the switches. And we can measure the data coming in and out of every device that has SNMP capability, including the transmitter site. And in the case of a Nautel transmitter with SNMP, you can actually control and monitor all the aspects of the transmitter. It'll send you all the information back from the transmitter. I did a quick measurement using the iReasoning MIB browser, and it was something like 500 plus different readings that you can get off of the transmitter just in SNMP. Try and do that with GPIO.
Ooh, wow. Yeah, no, you're absolutely right. Absolutely right. So the iReasoning Networks MIB browser allows you to connect to your device and look and see what's available to manage it, correct? Do I have that correct?
That's correct. It basically, you load the MIB file into it, and you can actually go in and scan and pull the readings right off of the device or send commands to the device, all using the browser. It's just like using an internet browser. You're just interfacing and interacting with the SNMP management of each and every device on your network. And by doing that, you can kind of put together a map of how you want to manage your network. This is kind of where you start creating your roadmap of your network, is using a MIB browser. Just experiment with some of the information. Experiment with creating problems, creating faults, and seeing how you can create alternate logic using Snmp to choose another path, choose another route to get to the transmitter, or choose another route for the audio. Or if you have an audio silence alarm, we'll start getting audio from another source. And we've been able to do that with the Nautels actually have a little USB plug in the back and a little player in the Nautel if you lose audio. The only problem with the VS series is that it doesn't switch back to your original audio source when it's restored. So we can do that within Spiceworks, within Davicom, within Burke, within iReasoning as a browser, but it's not its user interface only with iReasoning, and even Wheatstone has the ability to do that. It can send a contact closure or send a trap that, given that condition, the audio is restored, can tell the transmitter to go back to the original source.
Ah, that is cool. I like that. So if I'm building a network, let's say I have a network in place, I'm doing AOIP, I'm using either WheatNet or Livewire or Dante, and my devices are Snmp enabled, but I haven't really built out a Snmp management system. I could do an iReasoning browser or a MIB browser, sit and experiment and play. I shouldn't say play, but we'll just say experiment with different facets of Snmp.
Come on, we're engineers. We play with it.
Very well then. I got some folks that always make fun of that. So I'm more than happy to play. I'm all about making mistakes, learning from mistakes, and growing from that. I'm not one to shun away from stepping into something. Oh, wow, that was a mistake. But you know what? I learned something. Good. Move on. Make the same mistake twice, then you're an idiot. But no, I'm only kidding. But so a MIB browser would be a good entry way of learning Snmp, getting more familiar with it, and developing, as you point out, a roadmap to where you should go or where you would like to go. Correct?
That's correct.
Okay.
And there's future uses though for Snmp. I mean, I think us in the IP world or in the broadcast world have really been, I guess, hesitant to really embrace a lot of what is available with Snmp and with all the technology that's been around in IP. And it is a stable and mature environment. I mean, Snmp has been around since 1992. It's not new. This is not new technology to the network industry. It's just new to the broadcast industry.
This is true.
We can make a lot of use of that, of not having to reinvent the wheel. One of the big things that of course, has been coming out in the last few years, and a big discussion in Europe in September of last year, was AES 67. And for those of you who are not familiar with AES 67 and the AOIP, the audio over IP environment, where all of your audio is going through a managed network, is that the AES 67 or IEEE 1588 set the clock speed so that audio can be visible to all devices that support that clock speed, that AES 67, whether it be Livewire or Ravina or Wheatstone or Logitech. I mean, it doesn't matter who the audio is coming from. It's a universal clock speed. However, that's only one of three different things that you need for audio over IP. We need the clock speed. We need discovery so that we know the audio is there and how to address it. And we need control. Well, I understand the desire for every manufacturer to protect a lot of their programming and a lot of their trade designs, and there's no reason why they shouldn't. I mean, they've got a lot of time and money invested into it. However, the whole purpose of Snmp is to do discovery and control of any IP device on a network. There's an answer.
And the answer?
The answer is that solves our whole AOIP interoperability between multiple platforms.
So what you're saying is if they're willing to work together, Snmp could be the glue that brings it all together for us in the broadcast industry to enjoy interoperability amongst the premier products.
Well, since 1992, that was designed to do discovery and control. And I had the chance at NAB to talk to a lot of the engineers. I talked to Greg from Telos Alliance. I talked to Kelly over at Wheatstone. I talked to the guys over at Ravina. And that was the big discussion, is that, well, we have our own discovery and control system. Everybody has their own discovery and control system, but they also have Snmp, or in some cases they haven't turned on all of the Snmp availability, but it is there. I mean, one of the things about a MIB browser or like iReasoning is that you can really start going through that IP device and see exactly what is in that device for command and control and availability, and it's just not turned on yet. It's set in read-only mode. So there's a lot of ability to do discovery and control within IP-based devices. I actually spent a few hours last night going through a Wheatstone blade, just looking at all of the information that was coming out of Snmp. A lot of it was read-only, and you couldn't use it other than to just get information, but you could receive traps and everything else, but there's no reason why they can't turn on some of this technology through Snmp, which is a universal open source platform, and have control of AES-67 or AOIP across multiple platforms.
I like it. This sounds like a presentation you should be preparing for CCBE in September.
Actually, it's part of the white paper I have to deliver.
See, I was thinking already. This is going to be a fun fall. I like this. This is going to be fun.
So you're coming up to CCBE this year, aren't you?
I come up every year, yes.
Excellent.
No, it's great. I get to see a lot of folks I've made friends with and people. When I worked for a radio station that my co-channels were up in Canada, we got to keep in touch and talk. And Wally Lennox over at, I think it's now Astral, right? Is that right? It's Astral. I was losing track.
Well, Astral was sold to Bell, so Astral.
Sorry,
is
Bell,
now
right? Bell
mostly
Media,
Bell,
Astral now. So Wally over at CFRB, and then I know Dave Simon, who moved on because of good things for him, and he was at Bell, and a few other folks I bump into all the time. So it's like this is it's a great time to get up there, meet some folks, catch up with stories, meet folks like you with technology you're talking about.
You probably know Ron Comden.
Yeah.
Well, Ron is he's my counterpart at Durham. The two of us share engineering responsibilities for all 8 of these stations between Durham and Pine Ridge. We talk every day, literally.
Oh, wow. I bet, yeah, because let's see, we did 2 years ago with the golf course. We did a wireless video. I did a project with the CCB folks. We did a wireless video on the golf carts. I'm not sure if you were there for that show. But yeah, Durham, and now, yeah, we've talked. We've definitely talked. Cool. So, well, for those in the audience listening, CCBE, Central Canada Broadcast Engineers, it's it's September. I think it's late September 25th or 26th. If you have the opportunity to go north.
It's the perfect time to hit the golf course in Barrie, in that beautiful resort town.
Let me tell you, last year and the year before, but last year we had some of the best weather in Barrie that I've had up there in a long time. Everyone was like, wow, this is impossible. I can't believe it. And the greens were very busy. Very busy.
Yep.
So it's a good time. So you're probably you're submitting your paper with Chris Robitel?
I believe so, yeah. I know that, it's Ron that told me I had to submit a white paper, so I have to write it.
He's on the committee. Yeah, he's on the papers committee as well. Yeah, I think there's a couple of guys. Okay, great. Oh, yeah, it should be fun. We should have a good time. We'll definitely make sure we all get together and have a good time. So what else? Let's see. So with Snmp, we've solved the problem with Telos talking to another product talking to a Comrex, another product talking to a WheatNet. So now we've got something going on. How do you see Snmp evolving for broadcasters? As you say, broadcast industry tends to be a little slow in adopting things because of our 24/7 mission critical, always on, afraid to rock the boat type of approach. Do you see it becoming more integral as IP becomes more popular, I'll say?
I think it's part and parcel. I mean, Snmp is part of the IP design and structure. It was created in 1992, and this is back in the times of the internet, and when the internet was just starting to get going. So it's always been there. It's kind of like forgetting to check the tire pressure on your car. The wheels go round, but sometimes you may have a tire pressure that's running a little bit low, and you forget to check the tire pressure. It's basically Snmp is like checking the tire pressure or controlling what's going on in the car. The check engine light has come on. Well, that's the Snmp trap being sent to your dash. That's the whole idea of Snmp is part and parcel of the IP industry. We've just not grasped it. It's always been there. It's always been in the managed, even unmanaged switches I have a few unmanaged switches that have Snmp traps that you can, it'll send alarms if there's a failure or a disconnect on one of the ports.
Okay. Now, with Snmp, we're controlling devices. The device could be a computer. It could be a hardware device like a codec. I used to use a product called software called Naganos. Is that right? Is that how you say it?
Yes.
And for a radio station building out a facility or a group of stations that have their own private network, do you see, is it a good idea to invest in some type of application or software server that does Snmp trapping and monitoring of other things like computers, your automation system that controls your commercial playout or music playout? Or now we move from the transmitter control, audio codec path control, now to the in the studio. What else do we have that could make sense to take advantage of Snmp, and how do we keep our systems robust?
Well, yeah, you can use software and you can load it onto your computer. If you're running a RAID array for your playout system, which I strongly suggest you should be running a RAID array. If you're not, you're just playing Russian roulette with your hard drive on a live on your computer system. You can monitor that RAID array to make sure that the RAID array doesn't have any issues, or that there's no dead spots on the drive, or, for example, that the fan is at the right speed. I mean, we've all gone into a studio that might have a computer or some device that's cooled with a nice quiet fan, but the fan isn't quite so quiet anymore. And usually if it's not so quiet, it's also not running at the right speed. So Snmp can actually measure that fan speed and bring that information back through that you've got to replace a fan. Here's a general example of what we're using. We're using Davicom products. We're using Spiceworks, which is an ad-driven software management package that will, a network management package that does everything from creating work tickets for your staff, your technical staff, right up to and including, I'm just watching here that I know that I'm in a live studio and they're going to be coming up very quickly to a traffic. But you can manage every aspect of the computer systems, your surfaces that are IP-based. Again, you can look for any problems or issues or disconnects that are having silence alarms. Chris, the imagination just goes endless as to what you can manage, right down to the lights that light up on the studio when the studio's mic is turned on.
Perfect. That's exactly the line I always tell folks. I was at a university the other day talking before some students in a broadcast curriculum at the radio station, explaining how to understand workflows in a broadcast environment, commercial environment. And I've worked in sports, news, music, and talk shows, so I'm familiar with the format workflows. And they asked the question, well, if we do this thing with IP-related stuff, because they're all talking about using their laptops and audio servers and IceCast and all the the usual stuff that we talk about when you do web streaming and things of that sort. And they said, well, what can you do? And my line at everyone has always been, you're only limited by your imagination. And the fact that you've said the same thing, and we're talking about command and control of devices, and you're talking about you're limited by only your imagination, is so relevant. And I just want to impart that onto folks in the audience. Don't box yourself into, it's this, it's that, I don't know. Just take a look-see, read up on it, ask questions, find somebody that check your SPE chapter locally, and here in the States and up in Canada, we have a lot of engineering conferences and various organizations you can reach out to. And there may be people in your own market that you can reach out and say, oh, I didn't know you were doing this. What have you found as a success or failure? But I love the fact that you said imagination is the key. That's what I think we're missing in a lot of engineering practices these days. It's just, hey, I plug it in, I walk away, it's okay.
It's all
I'm
too
sure you
often,
run into that a lot.
All too often, engineering genius comes from having to find a solution to a problem, an off-air issue, an off-air problem. I mean,
yeah.
More often than not, I've been able to turn to IP and create a solution using either Snmp to control it or to monitor it. but I've been able to go to IP to create a solution on the fly, absolutely a lot faster than having to hardwire it.
Yes, absolutely. And I recently did that, about a month ago, did that for a broadcast group. They lost their connectivity to their transmitter facility. The only thing they could find that worked was some IP connection from a local DSL circuit that was being used by some communications company in their same room. It was a shared space. And they said, we don't know what we're going to do. I said, tell you what, I've got these 2 codecs. Put one at your studio. It's already been programmed to do X, Y, and Z. And let's do this one here at the transmitter, and we'll connect over the public internet, we'll call it, and we'll get you back on the air. What? You can do that? I'm like, believe it or not, you can. Then you can call the phone company and find out why your T1's not working. And we did it, and here we are 5 weeks later, they're still using the connection because of the T1 issues. Turns out the phone company had issues with their cable distribution in the building, and I guess the cable vault got compromised, and as we all know, phone companies are moving away from copper stuff and trying to become more wireless than wired.
To tell you the truth, I'm still dealing with that in the old POTS phone systems that's at our old studio location in Coburg. But we did have a T1 failure here that we kind of had an argument with the provider that a 1 hour response time didn't mean that it had to be offline for 8 hours before they considered it offline.
Oh, wow.
And we actually put the station back on the air using the guys are making fun of the background there. We used a tie line field unit and a tie line head end, very similar to a zip. And zip would have done it extremely well. Actually, probably would have been easier to do it with a zip. We just used a 4G hub and a tie line unit, went back to our internet connection here at the studio, which at that time was a cable connection, used Snmp and QoS, quality of service, to create a good, secure link over the internet. And we stayed on the air for 3 days using a field unit and a 4G hub.
I have done similar stuff, and I wish more people would be excited and try to explore that approach, and the things that come out of that. Once you do it, you're like, wow, wait a minute, if I do this. It's funny you mentioned that 4G hub, because I'm talking with this radio group right now, and they're asking me, how do we make this a more robust link using this approach? And I said, tell you what, if you get yourself a router that supports a failover to a wireless modem, you can keep the DSL approach, or if you prefer some other method like a wireless local loop ISP provider that has an SLA of quality that you can use. Now you have the ability to fail over to a wireless connection that you still control and pay for when you need to, and keep yourself connected while you troubleshoot the other side, but not impact the facility to the point where you're pulling cables and making a mess of things and you don't know what the heck just went wrong. So I'm glad to hear that.
That sounds like a Cisco RVO42.
Oh,
router.
I'm sorry. Did I inadvertently mention that? No. You see, this is what I'm talking about. Once you understand how these things work, and you can have some real good fun, at the end of the day, you go home, you can play the part of the hero if you'd like, and you just go home, everything is good, and that's it.
I keep a 4G hub in my toolbox. It's one of my tools. If I need internet anywhere, I've got a power inverter in the car, and I can power it up, and away I go. If I need a connection back to the studio with a codec, plug the codec, reprogram the codec to accept an IP address from the 4G hub, plug it in, away you go. It's literally that easy. You can reroute your entire path without having to call a contractor to come out with a boom truck and string new wire across a bunch of poles.
Yeah. As a matter of fact, at this past NAB, I was doing ad hoc presentations for a couple of customers who wanted to talk about moving forward with some technologies with codecs. And I brought with me my trusty Cradlepoint MBR95, and I set it up, at the table, covered it up with some things so you couldn't see it. Had the codec sitting on the table, plugged it in, and we started playing with it and playing audio and connecting to the far end here in my offices in New York. And they're talking, they're like, "Wait a minute, we're sitting at a table at the lunch area here at the convention. How are we connected? Yep. Where's you have internet connectivity from the show?" I'm like, "Oh no, I'm sorry. Did I forget to tell you?" And I lift the cover off the Cradlepoint and show them it's a 4G wireless connection we've been playing with for the last 30 minutes. And they haven't had any dropouts. We've been running 128 or 192 kilobits of AAC HE audio, both stereo mono for voice. They have a couple of voice applications and they have some music. And they're like, they didn't even think to ask first when we sat down, where is your broadband connection coming from? They just saw the device, started talking, and just assumed that it was connected to something wired because of the days of phones.
It just makes us all look like magicians. It keeps us employed, Chris. It keeps us employed.
Exactly. Well, listen, we've come to the end of our time allotted for the netcast, I'll say, or as we broadcast out to everyone. So those of you who have stayed with us, thank you. We enjoy your company, and we hope that you've enjoyed ours. And for those of you who have tuned in and have enjoyed this on demand, thank you for the downloads. So this week in Radio Tech, episode 210, Charlie Tona. Charlie, you have any parting words, anything you want to say hello to anyone up home area? Maybe somebody's watching and just want to be a hero and say, I'm a video star right now.
Well, I'm just going to hand off to the radio star that's coming into the studio here that's starting his live drive show. I'm actually cutting into about 5 minutes of it, Jay Thuler. And I know you didn't. I know you voice tracked that weather.
Oh, my goodness. We're interfering with that.
So he's been waiting in the wings. And say hi to my son, who's working hard out in the yard at Rental Center in Coburg, and my daughter, who's at college in Fredericton, New Brunswick.
Excellent. All right, you heard it here. We're interfering with an afternoon drive show. We should move things along. We can't interfere with their revenue capabilities. So, my name is Chris Tobin. I'm co-host for the show. Kirk Harnack could not be with us. He is somewhere down under enjoying the Australian outback with very little bandwidth, so he's used that excuse to go out and enjoy some other things. I'm sure he's holding a koala bear right now. Maybe not. Anyway, this is episode 210, Snmp. That's the protocol used for managing devices on an IP network. Look it up for more details. All right, thank you very much, Charlie. We appreciate it, and thank you all for tuning in and downloading us on demand.